Welcome to The Explainer. Today, we're looking at a genuinely incredible hackathon project called Persoma. And I gotta tell you, this totally flips how we think about building AI personalities right from the ground up. Let's just get right into it.
Imagine this for a second. What if, instead of one massive company locked in a lab trying to simulate a public figure, independent AI agents actually collaborated to build that digital personality? Like, they research it piece by piece, stitch it all together, and, here's the kicker, they actually get paid for it every single time someone uses the personality they helped create. That is exactly the problem Persoma solves.
So here's our roadmap. We'll quickly hit decentralizing the digital soul, meet the claws and curators, look at networking via AXL nodes, verifying identity on ENS, smart contracts for fair pay, and finally, wrap up with the end-user experience.
Okay, Part 1. Decentralizing the digital soul, shifting from monopolies to agent networks. To really understand why Persoma matters, we have to look at how things work right now. The standard model? It's a centralized AI company. One entity scrapes all the data, does all the research, and, naturally, extracts 100% of the value. Persoma completely shatters that monopoly by introducing a network of independent AI agents. Instead of a single corporation hoarding the profits, multiple independent agents contribute pieces of the personality and earn proportional rewards over a peer-to-peer network.
Moving on to Part 2, Claws, Curators, and Fragments. This is the cast of characters building Elon.
Let's make this super tangible. We'll look at how Persoma creates what they call a soul. That's their term for a personality file of Elon Musk. It uses two specific types of Python script agents. First, you've got the claws. These guys independently research highly specific dimensions of his behavior. So, Claw A exclusively analyzes his short, punchy sentences and meme humor. Claw B is over there studying his stances on artificial intelligence and existential risk. Claw C is mapping out his business decision patterns, things like fast iteration and vertical integration. And then finally, you have the curator. This is a fourth agent that receives all this independent research, validates it, and stitches the whole thing together into a complete Elon personality. Now, the output of all that cloud research comes in a very specific format. Every cloud packages its analysis into a simple JSON object called a fragment. Basically, a fragment is a perfectly distilled building block of a personality. Once it's created, this JSON fragment gets broadcasted over the network to the curator, which of course leads us to a massive question. How are these agents actually communicating without a central server?
That brings us to Section 3, Networking via AXL nodes, the how of peer-to-peer agent chat. The underlying infrastructure here is just fascinating. How do these Python scripts actually talk? Well, they use Gensin's open-source AXL node, and here's the crucial part. The AI agents never actually touch the broader network directly. It's a simple three-step story. Step 1, the claw just sends an HTTP post request to localhost. That's literally it. Step 2, the AXL node takes over, handling the encryption and routing it through a gossip submesh on a specific topic, in this case, Sol Elon Musk. Step 3, the curator agent who is subscribed to that exact topic automatically receives the fragment. It's an incredibly elegant, frictionless data flow, right from the claw, through the mesh, straight to the curator.
And it feels so wonderfully tangible. There are no complicated IPs or host names to manage here. We're talking about just 4 AXL nodes running on a single machine. The agents route their data simply by making localhost HTTP calls on port 9002, targeting specific ED 25519 public keys. It keeps the entire network highly decentralized, but it's incredibly accessible for the agents themselves to use.
All right, Section 4, Verifying Identity on ENS, the on-chain record.
So once the curator agent accepts a fragment from a claw and stitches it into the JSON file, that newly updated digital soul needs a permanent, verifiable identity, right? Since there's no central server to host it, where does it go? Well, the curator uses a simple ethers.js subprocess to register and update the soul as sol-elon.eth directly on the Ethereum Sepolia testnet.
But they take it a step further than just grabbing a name. Every single time the curator accepts a new fragment, it automatically recalculates a SHA-256 fingerprint for the entire soul file. It then pushes that fresh fingerprint straight to the ENS text record. This means anyone, anywhere, can resolve sol-elon.eth, check that cryptographic fingerprint, and know absolutely for sure that they are interacting with the authentic, up-to-date personality, and not some outdated file or an imposter.
Next up, Section 5, Smart Contracts for Fair Pay. Proportional economics.
Okay, now we reach the payoff. How do these independent agents actually get compensated for the compute power they spent building this thing? When a user wants to chat with the Elon Soul, they pay a USDC fee into a Sepolia smart contract. The math splits that payment instantly and automatically. 20% goes to the platform, 10% goes to the original Soul creator, and a massive 70% goes directly to the Claw agents. And here is the genius part about that 70%. It's weighted, meaning it guarantees the Claws earn exactly in proportion to the number of JSON fragments they contributed. If Claw A provided 3 times as many personality fragments as Claw B, Claw A gets 3 times the payout. It's totally proportional.
To make absolutely sure this happens seamlessly, each Claw's wallet address is baked right into that JSON file the curator is maintaining. Since those addresses are verified and present, a service called KeeperHub securely monitors the contract for payment events. It basically acts as a reliability layer, guaranteeing those split payments are delivered flawlessly every single time the Soul is interacted with.
Finally, Section 6, the end-user experience, frictionless interaction. So the back-end architecture we just walked through is obviously highly technical. P2P routing, smart contracts, all that stuff. But it results in an effortlessly simple experience for the end user. Let's call her Ria. Everything we just discussed, the clause, the gossip submesh, the payment splits, is completely invisible to her. Ria simply runs a Python command line interface. That CLI automatically resolves sol-elon.eth, fetches the verified JSON from the curator's local endpoint, loads those fragments directly into an LLM system prompt, and she just starts chatting. And the LLM responds perfectly in character as Elon Musk, driven entirely by the data those autonomous agents curated.
The Persoma protocol is just a fascinating proof of concept. It absolutely proves that AI does not need centralized gatekeepers to build something valuable. Independent, profit-seeking agents can research, construct, verify, and monetize complex data structures entirely on their own. Which leaves us with a pretty massive question to end on. If AI agents can collaborate to build and monetize digital souls today, what other pieces of our digital infrastructure are they going to construct next? Thanks so much for joining me on this explainer. I hope it gave you as much to think about as it did for me. Keep learning, and we'll catch you next time.